Now that we've reviewed the methods of inference, let me go ahead and use those to complete my assignment for Instructor Report 2. Here's the assignment. Write Report 2. Begin by copying your notebook for Report 1. You are welcome to modify this if you have learned how to improve on what you originally wrote for Report 1. Then add inferential statistics to the report to provide a more complete analysis. You should add inference to correspond to each of the three analytic sections of Report 1. A, examining the proportion in the sample from each SES category. B, comparing reading scores for the SES categories. And C, comparing the proportion in different SES categories for different ethnic groups. You're going to see something very, very similar when you read the instructions for your report. It parallels exactly what it has here for me to do in my report. Namely, in a nutshell, what we're doing is expanding on Report 1 by adding inference. So that's what we're going to look at in my report right now. You should recognize this from what I presented last week. Most of the report is identical to what I went over with you last week. I'm going to just look at the inference that I added to this report and discuss that inference. Now, in this video, I'm not going to show you how I actually did this inference using R, but I have separate videos to show that for each of the three sections where I added inference. So rather than looking first at the R code, we're going to look at the actual inferential statistics and the interpretation of those statistics. You may recall that in the first analysis, what I had to do is compare the proportion of students that came from each of the low, middle, and high SES groups in the sample. There were 23.5% in low, 47.5% in middle, and 29% in high, as illustrated in these bar graphs. So notice what I have added. I'm basically adding confidence intervals for a proportion, and I'm adding 3 of those because I have 3 different proportions. I have the proportion in low, the proportion in middle, and the proportion in high. So here is what I say. From these estimates, I can infer with 95% confidence that the proportion of high school seniors who come from families in the low SES category is between 0.18 and 0.30. If I had stated this between 18 and 30% of high school seniors come from low SES, that would be the same thing. That would be perfectly acceptable. You can do it as either a proportion or a percent. Similarly, the proportion of high school seniors who come from the middle SES category is between 0.40 and 0.55, and the proportion from the high SES category is between 0.23 and 0.36. So I have constructed 3 confidence intervals, each with 95% confidence. Let's take a look at the first one. I have 23.5% in my sample. From that, when taking into account sampling variability through a margin of error, I have between 0.18 and 0.30. So 23.5% is always going to be in my confidence interval. That is, your sample estimates are always going to be in your confidence interval, so there's no need to ever say that to a reader. That's a given. What's of interest is that 23.5% is a point estimate, but that point estimate doesn't have any confidence with it because we're not taking into account the sampling variability. If I had taken another sample of 200 high school seniors, I would have arrived almost certainly at a different number than 23.5%. So in order to have confidence about the proportion that are in low SES, I need to construct an interval. and that interval is based upon the standard error of my sample statistic, which in this case is a proportion. Remember that standard error is simply the estimate of the standard deviation of the statistic. Once we have the standard error, then we also have to take into account the probability based upon how confident we want to be. For higher levels of confidence, we're going to have a wider confidence interval, that is, a larger margin of error. If we're willing to have lower confidence, then we can have a narrower confidence interval with a smaller margin of error. In this case, I want it 95% confidence. So that provides me the lower bound of 0.18 and the upper bound of 0.30 for the proportion that are in the low SES category, with 23.5% being my sample percentage, or we could have expressed that as 0.235 as a proportion. I construct similar confidence intervals here for the middle and the high SES categories. The point estimate is more precise, but the range estimate for low SES from 0.18 to 0.30 allows us to attach a level of confidence to our estimate. The next part of the analysis looks at a comparison of reading averages for the three SES groups. We're going to focus here on the mean. Now, I prefer to look at the distribution as a whole, but when we do inference, we're going to have to pick out a statistic, so we're going to use the mean. The reason I provided these side-by-side box plots and the corresponding statistics that you see here in Table 1 is because I want to look across the range of the data. I want to look across the whole distribution. But now for our inference, we're going to focus on those means. The point estimates were 48 for low, 52 for middle, and 56 for high. Let's see what I've done with confidence intervals. From these data, I estimate with 95% confidence that students who come from middle SES families will on average score between 0 and 7 points higher than those from low SES families. The lower bound of this interval is 0. This would mean that there's no difference in the population mean for low and population mean for middle SES high school students. It's easy to get caught up in the fact that 0 is in our confidence interval. 0 being in the confidence interval would correspond to getting a p-value for a hypothesis test of the difference in means that would not let us reject the null hypothesis. But consistent with what is being advocated by modern statistical reforms, let's not turn this into a binary decision. Statistics is a way to take evidence to be able to say something about our population based upon what we see in our sample with a certain degree of confidence. That degree of confidence is arbitrary. We could have chosen 93% or 90%, in which case 0 would not have been in the interval. What I would say about an interval in which the difference goes between 0 and 7 is that the evidence is that students from middle SES families are likely to score higher on average than students from low SES families. Maybe I don't know that with precisely 95% confidence. Our confidence intervals are really never precise. They're based upon some conditions for valid inference that are never exactly true. Therefore, I'm never exactly 95% confident anyway. So what I'm observing here is that I have a confidence interval that is almost entirely above 0. But what I'm also going to observe is that because it does go down to 0, the average score for the population of middle SES students may not be much higher than that for low SES students. Again, let's not make this a binary, are middle SES students scoring above lower SES students. Let's also consider how much they are scoring above. It could be almost nothing, but it could be as high as 7 points. If I want to have a more precise confidence interval, I need a larger sample. Our statistical estimates will have less sampling variability when we get larger samples. So the width of our confidence interval is a function of the decisions that were made regarding how many observations to look at before we construct those confidence intervals. The other two confidence intervals have a similar width to them, but are a little bit more unambiguous concerning the possibility of 0 being in the interval. We estimate that students who come from high SES families will on average score between 4 and 12 points higher than students from low SES, and between 2 and 8 points higher than students from middle SES. That's still a fairly substantial range. But between 4 and 12 points, depending upon the nature of the test and what kind of reliability is associated with the test, could be substantial. Less so when we're looking between 2 and 8 points, but nonetheless, we do know that students from high SES families score lower than those from middle SES families, and we know that that average could be fairly small, 2 points, or quite a bit higher, 8 points. Finally, that brings us to the third section of the analysis, in which I look at the difference in proportion of SES category within each of the ethnic groups. Now, if you look here at this bar graph, the stacked bar plot, note that there are many different pairs of proportions that I could compare. I could compare high SES for Hispanic to high SES for Asian. I could compare middle SES for Hispanic to middle SES for African American, low SES for Asian to low SES for white, and so on and so on and so on. Too many of these to do. So what I'm going to do is exemplify this by simply comparing the 3 SES categories for African American and white high school students. So in my first confidence interval here, I get that from these data we can infer with 95% confidence the percentage of African American high school students who come from a low SES home is 13 to 64 percentage points higher than the percentage of white high school students who come from low SES homes. Now there are a couple things that are obvious here. One is certainly we can say that more African American students come from low SES than white students, but also notice that in terms of saying how much more, that's a pretty broad confidence interval. It could be 13 percentage points higher, or it could be as high as a whopping 64 percentage points higher. That's because we have low sample size. Remember that the margin of error is based upon the standard error of your estimate, which in this case is the difference in two proportions, and that it involves the size of the sample. The smaller the size of the sample, the bigger the standard error, and therefore the bigger the margin of error. The higher the size of the sample, the smaller the standard error, and therefore the less margin of error and the smaller, narrower confidence intervals that we would have. Now we have a sample size of 200, but note that that's the total sample size. That's not just African American and white students, and it certainly is not low SES African American and low SES white students. So our frequencies are quite small within these cells, and we end up with a very wide confidence interval. Nonetheless, statistical inference is about using the observations you have at hand to arrive at new information that you can infer outside of your study. And in this case, we do have new information. We do know that even outside of our study, we expect to see more African American high school students coming from low SES than white students, and that would be at least 13 percentage points, but maybe substantially more than that. The percentage of African American high school students who come from middle SES homes is anywhere from, listen closely to this, 4 percentage points higher to 45 percentage points lower than the percentage of white students who come from middle SES homes. This is not only a wide confidence interval, but it's one that goes on either side of zero, and those are the intervals that are most difficult to interpret. What is this telling me? I will tell you right now that I'm not going to do what most people do who interpret p-values. The fact that zeros in the confidence interval here means that the p-value for a hypothesis test about zero is going to be greater than 0.05. I'm picking 0.05 because we're using 95% confidence intervals. Individuals often will interpret that as there is no difference, but that's not in fact the case. If we look up at the bar graph up here, we see that there is a difference, and the statistics support it down here in the table. A higher number of white students were from middle SES than African American. The question becomes, can you infer that's the case in the population? Not with 95% confidence. However, the evidence does suggest, even looking at that interval, that a higher percentage of students from white homes are going to be from middle SES backgrounds than African American students are. But that may not be the case. I'm not 95% confident. Again, I'll reiterate, statistics is about gathering evidence. The evidence here is not as strong as I would like to be, that more white students are going to come from middle SES homes, but there is evidence that that's the case. If I had used a lower level of confidence, I may well have turned out with an interval in being narrower that did not include zero. I don't know that for sure because it would require me to take another sample and try this again. So what I get from this is not as conclusive as I would like, but I still have evidence, and I should not ignore or shun that evidence. When I compare high SES, the percentage of African American high school students who come from high SES, again, is between 2 percentage points higher to 38 percentage points lower. Again, that 95% confidence interval with the margin of error we have is too wide for us to be conclusive at the 95% confidence level. The evidence suggests, however, that white students tend to come from high SES homes in greater rates than African American students. What I would further say, though, is that more study is needed in order to be able to get a narrower interval and have more evidence if this was really important to us to confirm. I changed nothing at all in the press release, and in the conclusions, I just took a couple of exemplars based upon the analysis I did above and did not repeat all the different confidence intervals, but took exemplars that help make my point regarding conclusions. I'll leave it to you to read those. In the next videos, I will go step by step through the R code I used in order to calculate these confidence intervals.